Okay, here are a few quadratic formula examples to get you started on the practice for today. So these first couple of problems have this nice little skeleton fill in the blank for you. The directions remind you that you need to set each equation equal to 0 first. So if you don't see this equal 0 situation, make sure you get out all of the variables on the same side and make sure you have squared term, your singlet term x to the first, and your term with no variables, and you keep them in that order. And then I like to fill in either above them, or I like the boxes are nice. Here, 3 is our A, 10 is our B, and 5 is our C. If I don't have those boxes to fill in, I might just write those off to the side instead. A goes 3, B goes 10, C goes 5. And then you can fill in the boxes, or you can fill in the equation when you're ready. So, our equation goes like this, and this is again to find the roots or solution. It's just another way to find where our graph crosses the x-axis. So the opposite of b, our b is 10, plus and minus the square root of b squared, so b is 10 again, minus 4, a is 3, c is 5, all divided by 6 times a, and our a was 3. So it's just filling in those blanks, and you can make those blanks for yourself if that isn't there for you. And then our next step is to, in our calculator, put in everything that's under the square root, but not the square root. You want to put it in exactly like it looks, and remember, these are multiplications. I'm going to put those in front. So I'm going to pull out my calculator, over to the side. Again, I'm just going to put that stuff that I put a box around in yellow. And as I'm working through these problems, a great way to work with your video is to pause and try the problem on your own. So right now, pause, put in 10 squared minus 4 times 3 times 5 in your calculator, and then see if you got what I got. So hopefully you paused, and now you're back, watching me do it and making sure that you got the same answer that I did. So under our square root is going to be a 40. So we're just replacing. We're just doing the baby steps. Under our square root is going to be a 40. Everything else is going to stay the same. So I have negative 10 plus and minus our square root over, and I think I might go ahead and do this 2 times 3 down the other. 2 times 3 is 6. And then we said under our square root was 40. And that's a really nice exact answer. We can simplify it. We can simplify the square root. We can simplify the fractions. But that's a really nice exact answer. Again, for a lot of these problems that we talked about on the first day in the notes, if you graph them, you would get a decimal answer. Most of these are going to be problems where you're not going to get a nice answer like that exactly. But the nice thing about quadratic formula is that it always works. So the next thing we're going to do is keep dealing with those square roots. So 40, if we do a factor tree and think about our perfect squares, the biggest perfect square that goes into 40 is 4. So I can change this square root of 40 into square root of 10 times square root of 4. And the square root of 4 is 2. So I'm going to change the square root of 4. The square root of 4 is 2, so I'm going to put that out front. And then I'm going to leave the square root of 10. We can't break that down. That's not divided by 6. So I'm trying to color code for you. I'm only changing one thing each step, and that is definitely the way to go about it. Our last step to make a beautiful exact answer here is to do some work with our fraction. We really have 2 fractions here to work with. The negative 10 over 6 and the 2 over 6 are the 2 fractions we really need to work with. So I'm going to rewrite those like this. Negative 10 over 6 plus and minus 2 square root of 10 over 6. And those are the fractions that we can reduce. And you can do math, enter there in the calculator. I know a lot of you like that. So negative 10 over 6, negative 10 divided by 6. Math, enter, enter. There's our nice fraction, negative 5 over 3. Plus and minus 2 6. Well, a lot of you can do that in your head. That's 1/3. You can write it separate like that. You can write it together. That is a beautiful final answer. The way you would see that on a key would be this. Just everything over 3. That's how a lot of the final answers would look. Now that's 2 places on your, that's 2 places where our graph is projecting the y-axis, or the x-axis, sorry. And we talked about that in class when we did the notes. So these are just exact answers. And when you graph it on Desmos, you're going to find some approximate solutions instead. All right, let's do another example. Again, this one has the nice little boxes for you. And we have n's, but we can use x's. Those are really interchangeable. So 3 is our A, negative 12 is our B, and positive 5 is our C. And taking those positives and negatives with you is really important. So I'm going to put negative 12 in my box for B for both of these. And use some parentheses there. A is 3, so I'm going to put that in both my A boxes. And 5 is C. And remember, over here with the 3, 4, 3, 5, that's all multiplication. So a little different with this one just because our B value is negative. Here I have a negative 12, so it's going to be a positive 12. Just like the last problem, actually the bottom, our denominator in our fraction, is 2 times 3 again. So that's just going to be 6 to the bottom there. And now, same thing to put in our calculator. I'm going to put this all in our calculator all together. So, negative 12 squared minus 4 times 3 times 5. And it's 84. So I just replaced. My negative 12 became a positive 12. My 2 times 3 in the bottom of my fraction became a 6. And that whole mess under the big radical sign became 84. And now we're going to work with that 84 and see what's the biggest perfect square that will go into it. So for 84, I'm going to start by dividing by 4. 84 divided by 4 is 21. Okay, so let's try another perfect square. I'm not going to try 9, but since 4 worked, I'm going to try 16. 84 divided by 16 doesn't work. So I think 4 and 21 is going to do it. So 84 is the same as 4 times 21. And the square root of 4 is 2. So I'm going to change my square root of 84 into 2 times square root of 21. And everything else about my problem is going to stay. And again, I'm changing my square root of 84 to 2 square root of 20. That is a beautiful final answer. But in Algebra 2, they are going to want you to do a little bit with this fraction here. We can divide all of the, you can break it up, or we can divide all of the things outside the radical by 2. I'm going to go ahead and break it up. I like 12 over 6 is 2. 1 over 6 is 1/3. So that's another way you could see that. The plus minus in the middle gives you 2 solutions. All right. This is the last example I'm going to do for you. Hopefully this has helped get you started. The first step we have to take on this problem is to get everything set equal to 0. So I'm going to subtract over the 9x. This is a great opportunity for you to pause and see if you can get all the numbers plugged into the quadratic formula on your own. So go ahead and pause and see if you can label A, B, and C, and then plug the numbers into the quadratic formula. Okay, hopefully you paused. I'm going to label A is 2, B is -9, and C is +2. If you find yourself wanting to put the x's into the formula, don't do that. Just write it like this. We're finding what x equals. We don't need x in our formula. Okay, so take a look at, hopefully you took a look at the little boxes that you've been filling in. X equals, that's the only place your x goes in this formula. We're going to do the opposite of b, so -9 plus minus the square root b squared, and our b is -9, minus 4 times our a is 2, our c is 2. Whole big divide by sign goes under everything. 2 times, and our a is 2. That's all plugged into our formula. Now we take the mess under the radical and we put that into our calculator. So in my calculator, I'm going to make this look exactly like it does on the screen. Pull a little bit so you can see both of these. -9 squared minus 4 times 2 times 2. And we're not putting in the square root, we're not putting in the 9 out front, or the divide by sign, just what's under that square root. And that is 65. So, I'm going to leave everything, well, I guess I'm going to do a little bit of multiplication here. So negative 9 is 9. And the bottom of my fraction, 2 times 2 is 4. And then we found out that mess under our square root is equal to 65. And now we want to work with that square root still. So what can we take out? Is there a perfect square that goes into 65? 65, let's see. The perfect square that's closest is 64, so I'm going to go down this time. 64 is too big. 65 divided by 49? Nope. 36 I think is going to be too big still. 25 isn't going to work. 25 goes into 75. 16. Nope. Still no nice numbers. So that was 4 squared. 9. Oops, I'm divided by the correct number there. 65 divided by 9. That was 3 squared. 2 squared is 4. Just going down my perfect squares list. And nothing works. So my final answer here is 9 plus and minus square root of 65 over 4. So those are the first 3 examples. Hopefully that was helpful to get you going. I think the best thing to do with these, again, like if you were going to start number 4, label. A is 3, B is -6, C is +3, and then plug into your formula. Do your radical first. If you can get to the point where your radical is dealt with, then try to deal with the fraction. Solutions for all of these problems with all of the work to them are posted on Canvas as well in the link above here. So if that is helpful to you, take a look at that to check your work. Thanks for your hard work.